Let's get going on this. This is homework number 7 for chapter 3. Currently, we're working on area model. And first one, number 90. What is the area of each part of the entire rectangle at the right? What is the area of the whole figure? Okay. What is the area of the rectangle as a product and the area of a rectangle as a sum? All right, so you notice that on the left-hand side, you do have the area model. Okay, and I'm going to go ahead and because we already have the dimensions, we have the length, which is x plus 8. I'm going to go ahead and start that off. Area as a product, it's going to be x plus 8 multiply by the width, which is x plus 3. So that's the easy part, and that's already given to you. All you have to do is just copy it down. Okay. Now the area as a sum is a little bit more work on your half. Right? So you're going to have to figure out the area of each of the parts. So the first part, so we'll say this right here, right? That part right there, that right there, you're gonna have to find the area of that part by multiplying x by x, and x times x makes x squared. So the area of the sum starts off with x squared. Oops, starts off with x squared. Okay, the next part, let's go with this right here, that right there. That right there area is going to be at 3 times x, which comes out to be 3x. Okay, I'm going to hold off on that, and you'll see why in just a second. Right, and then I'm going to find out the area of the next part, which is this part right here. That right there. This area. That right there is going to be x times 8, or 8x. Okay, and I'm going to go ahead and combine the 3x and the 8x because they are like terms. So 3x plus 8x makes 11x. And finally, I'm going to go ahead and figure out the area for that last part right there. This part right here, that's going to be 3. And we know it's 3 because this is 3. Okay, that's 3 because this is 3. So that's 3 times 8. And we know it's 8 because this part is 8. So that means that this part is also 8. So the area of that last rectangle is 3 times 8, or total is going to be 24. So that's your last piece of your sum. Okay, number 95, this is the last one. See, I told you this homework wasn't going to be too bad. Only 2 problems. Number 95, graph the line y equals 3/4 x on the graph paper right here. Okay, notice that y equals 3/4 x doesn't have a y-intercept. It's actually plus 0, which means we're going to start at 0 right here, and the slope is up 3 and over 4. So you watch how I was doing this. I'm going up 3, 1, 2, 3, and then over 4. 1, 2, 3, 4. And you can continue that trend of 3, 1, 2, 3, and over 4. 1, 2, 3, 4. Okay, run out of space. So in this case, I'm going to go over 4. 1, 2, 3, 4, and then down 3. 1, 2, 3. Over 4. 1, 2, 3, 4, and then down 3. 1, 2, 3, and then I'm out of space. You see that all of these points make a nice and perfect line. So I'm going to go ahead and draw my line there. Okay. draw a slope triangle. Well, my slope triangle, okay, and you can do it between any 2 points. I'm going to use the closest points. So my slope triangle, I'm going to do it right here. This is up 1, 2, 3, and over 4. 1, 2, 3, 4. So you were right. 3 right here and 4 right here. Rotate your slope triangle 90 degrees around the origin to get a new slope triangle. What is this new slope? Right, so actually, let's actually modify our slope triangle. Let's move it to this other one. And I'm going to put it in red. Right, so let's put it in red. That way we can see it a little better. Nice style. Yep, let's do red. Okay, so that's in red. So let's move it over. So it's right at the origin right here. So that way it'll be easier. Okay, so I'm going to rotate this 90 degrees around the origin. Okay, so you rotate this 90 degrees. Okay, so I'm going to turn this way, and this is counterclockwise. Now I have this, right? So, so it would be up 4 or down 4 or up 4 or down 4, right? Because if I rotate it, this would be down 4 and over 3. Okay. If I did it the other way, think about it. It'd be the same thing. If I did a slope triangle, you rotate it around the origin, it'd be down 4 and over 3. So it's the same thing, whichever way you want to rotate it. Okay. So if I do that right there, then my new slope triangle, and let me just kind of flip around this way. That actually doesn't work. Okay, so I can write my slope triangle as down 4 and over 3, and my line would look something like that. Okay, so the new slope is going to be, so remember the slope is going to be the change in y over the change in x. The change in y is going to be down 4 and then go over 3. Write the equation of the line perpendicular to 4/3 x. So if I have a line that's perpendicular to 4/3 x, then I would need to use, okay, this slope right here. I need to use this slope right here, except I'm not going to use m, it's 4/3. If I want a perpendicular, I need to use m, I'll use green in this case, m equals the flip, which is 3 over 4, and the opposite, which means negative 3 over 4. So my equation, and I can do it pretty much any way I want. My equation is going to look something like y equals negative 3/4 x plus whatever you want. So if I say plus 5, right? Okay, that should be the equation that's perpendicular to that 4/3 y, okay? Or 4/3 x, excuse me. All right, we'll call it.
Thank you.